Question 3, show that the equation 7 tan theta over cosine of theta plus 12 is equal to 0 can be expressed as 12 sine squared theta minus 7 sine theta minus 12 is equal to 0. This is a quadratic in sine theta. Okay, now using the trigonometric identities, we can see that we are not seeing here any cosine and tan. So express tan in terms of sine. So we shall have 7, then sine, remember tan is sine over cosine, right? Then times, there is this 1 over cosine, which is down here. So I can say times 1 over the cosine of theta, or I just write this one as cos squared theta, okay? Then plus 12, this one will be equal to 0. Now, I can multiply everywhere by cos squared theta. It will be the LCM because this one is over 1 and this one is over 1, right? Okay, so when I multiply all through by cos squared theta, automatically this one will disappear, and then we remain with 7 sine of theta, then plus this will be 12, then cosine squared of theta, which is equal to 0. And using the trigonometric identity, the Pythagorean identity here, we are going to have cosine. We write it in terms of sine. So this one is going to be 1 minus, then the sine squared of theta. Okay, then we can open the brackets. This is 7 sine theta, then plus 12, then minus 12 sine squared theta is equal to 0. Then I can take everything this side or multiply all through by -1 such that the coefficient here of sine squared becomes a positive. Okay, so when I take everything this side, what was negative now becomes a positive. So we shall have 12 sine squared theta. When this one crosses, it becomes a minus. So minus 7 sine of theta. Then the 12 will also become a minus 12, which is equal to 0. And that is exactly what they have told us to prove. Okay, then part B, hence solve this equation. Hence, start from where you have stopped or find a way of using what you have gotten in the next one here. So I'm now solving 12 sine squared theta minus 7 sine of theta minus 12 is equal to 0. This is a quadratic equation in sine theta, like I said before. So we can solve it using the calculator, okay? And then from there, but then again, you have to show the examiner that you have solved the equation. The attempt to solve the equation must be clear, okay? So let's check whether this one can be factorized. Now from here, I'll go to equation, that is 5, then quadratic is 3, A is going to be 12, B is -7, and then C is -12. Then when I press equals, that is 4 over 3, and then -3 over 4. So I'll skip space here, okay? And then I write that -3 over 4, and then the 4 over 3. So sine of theta is going to be equal to -3 over 4, and also sine of theta is equal to 4 over 3, okay? Now, we need to show the examiner that we have solved the equation. When you write this, you're going to lose a mark, all right? So first, get for us the factor from which these roots come, okay? Cross multiply, you will get 4 sine theta, then bring this one this side, it becomes a plus. So that means we are going to have 4 sine of theta, then plus 3. And then here, when you cross multiply, it will be 3 sine theta is equal to 4. Then take the 4 this way. So this one will therefore give us 3 sine of theta, then minus the 4 is equal to 0. Now, we know that sine ranges from -1 to 1. Okay, so this one is 1.3 recurring. That means when you get the arc sine of this one, it will be math error. You won't get any solution. Okay, so that means this one is undefined. Actually, to make it so clear for you, this is what you can have. Now, let's have y, which is equal to the sine of theta, sine of that x. You can see that the maximum is a 1, which is here, and then the minimum is a -1. Okay, now when I have another line y, which is equal to 4 out of 3. 4 out of 3. You see that line here, 1.3 recurring, it is not meeting this curve. So there is no solution. But if I put something like, this one is, the other one is -3, okay? Here is -3, then out of 4. -3 out of 4. Yes. So that one here, we can see a solution here, 3.98. But of course it is in radians, okay? Even this other one here. So that is where we are having the solution because the line meets. But for the other one, it doesn't. So that's why we say it is undefined. Even the calculator gives you math error. Now let's go to this one here. For us to get the value of theta, it is going to be the arcsine of -3 out of 4. Now, when we look at the 4 quadrants, our sign is, this one is negative, okay? So if it is negative, then that means that we are supposed to get the angles in the quadrants where sign is a negative. And this is, here in the first one, all of them are positive. Here only sine is positive, only tan is positive, only cosine is positive. That means sine is negative here and then here, okay? Then from there, suppose I project this one as my x here, and then I also bring it this way. Opposite angles are equal. Even here, I put that x, and then I also take it here. It will also be that x there. So this is 0. When we move anti-clockwise, the angles are positive. This will be 90 degrees. This is 180 degrees. This is 270 degrees. And then by the time you come back here, this is 360 degrees. So to move from here up to here, that is the same as saying this is 180, then minus the x which you get here. So that means to get the angle in the second quadrant, it is 180 minus theta. Then to get the angle in the third quadrant, it is 180 here, then plus the x here. Okay, so we shall have 180, then plus the x. And then this other one here in the fourth quadrant, you are moving from here up to here. So you just get the 360, then minus the angle that is here. Okay, for these angles, we look at the deviation from the horizontal angles here, the 0, the 360, and 180. Now, what you can do here, because when you get the arcsine of this, this negative here, the calculator is going to give you a negative value, but you don't have that what? Negative. You don't have the answers in the negative region. These ones we are considering from 0 to 360, the angles are positive. So what do? Ignore the negative. When you ignore the negative, the calculator is going to give you the positive angle. Then from there, you go to the quadrants where sine is negative. So it is here. So you will say 180 plus that acute angle you have gotten, and also 360 minus that acute angle you have gotten. Okay? Now, since the domain given here is from 0 to 360 and it is in degrees, that means your calculator should be in degrees. All right? So mine here is already in degrees. We shall press now shift, then a sign that will be now the arcsine. We just put 3 over 4. I said ignore the negative. Then we get our 48.6. That is to 1 decimal place. Okay? Now we keep it somewhere. Now, your theta here is going to be, you go to the quadrants where sine is negative, it is here. So I will say 180 degrees, then plus that 48.6. And then the other one will be 360 degrees minus that 48.6 degrees. So that means our answers are going to be, of course, this one is going to be, subtract the 20 here. So it will be 228.6, and then this one here will be 311.4 degrees. All of them to 1 decimal place. Angles in degrees, we put them to 1 decimal place for uniformity. So that is that.